Okay, so I wanted to go through a couple of word problems with Trig just to kind of help you out. These are some of the problems from the assignment on Module 4.08. And I just kind of wanted to talk through them a little bit to make sure that you really understand what you're doing. First thing I want to do is give you a calculator tip. I don't know what kind of calculator you're using. I'm hoping it's one that looks like this. This is the one that I'm using. There is a button right here. I'll draw it a little bigger so you can see it. It's got a degree and then a hash and then two hashes. Okay, that's the button that you want to be using for the kind of problems that they're giving you, because they're giving you the measurements in degrees and inches so that you can, this will help you put it in your calculator correctly when you're doing it. Okay. So I just wanted to tell you, if you're not using this kind of calculator, hopefully you have this button on yours. If you're using a graphing calculator, I think it's in the mode or the math menu. I can't remember which one it is, and I'm sorry about that. If you shoot me either a picture of your calculator or just the model number, I can respond and tell you where this button or this function is. Okay. Anyways, okay, so we've got this word problem here. From a boat on the lake, the angle of elevation to the top of the cliff is 24 degrees 52 inches, 52 feet. If the base of the cliff is 944 feet from the boat, how high is the cliff to the nearest foot? So first thing I want to do when I'm doing these is draw a picture, okay? So I've got a boat on a lake. We've got our boat out here on the lake, and we know that there's a cliff, right? And the angle of elevation from the boat to the cliff is given by 24 degrees, 52 feet. The base of the cliff is 944 feet from the boat. How high is the cliff? So this is what we want to find. We don't care about the distance from the boat to the top of the cliff for this problem. We care about how high is the cliff, and we know that the boat is 944 feet from the base of the cliff. Which then gives us this right triangle that we can work with, okay? The angle of elevation is this bottom right corner as you're looking up to the cliff. Now, this is a pretty straightforward problem. We can set it up. I've got opposite and I've got adjacent, which means I'm using tangent for this problem. So tangent of my angle is equal to my opposite over my adjacent. So I'm putting x over 944. Now, here's the little tip, trick, whatever. If your number is on bottom, like the 944 is, multiply. If the number is on top, divide. Okay, so I'm going to take 944 times, and I'm going to put it in my calculator in this order too. I'm going to take 944 times, and then you've got some parentheses, tangent of 24 degrees, 52 feet, and I'm going to use that button that I just showed you on the last slide. I'm going to type in 944 times, and then tangent. And I actually think, sorry, I put that in the wrong place. On the calculator, the parentheses show up 24, so 24 degrees. And when you hit that button, you have a menu of different things you can do. And I'm just going to type them in. I'm going to arrow over to the first hash mark and hit enter. And I've got this all entered. Make sure you close your parentheses as well when you're doing this, okay? And then hit enter. And you've got 437.52 feet. And they want it to the nearest foot, so 438. Oh my goodness, I can't write. There we go. Okay, let's try another one. From a balloon 915 feet high, the angle of depression to the Ranger headquarters is 8514. How far is the headquarters from a point on the ground directly below the balloon to the nearest foot? So we've got this balloon that's up in the air, and they are looking down at the Ranger's quarters, okay? I'm going to draw my right triangle here. Now, here's the thing. Angle of depression is really technically this angle here. It's from the horizontal of the viewer's vantage point. However, that angle is not in our triangle. It is, however, based on what we know from geometry, congruent to this angle down here. Now, here's my little helpful hint. Whether it's angle of elevation or angle of depression, it's always this bottom angle, always, okay? Because the two are congruent, you can use the same angle every single time. Now I'm gonna label what I know. I know the balloon is 915 feet high. I know the angle is 8514. And the question is, how far is the headquarters from a point on the ground? So we're talking about this horizontal distance here. That's my x. Again, I have opposite and adjacent, so I'm going to use tangent of 8514 is equal to opposite over adjacent. Now this time my number is on top, so I'm going to take 915 divided by tangent of 8514. And I'm going to type it into my calculator exactly like this. I'm going to use my parentheses. I'm going to use that degrees and feet button. I'm going to close my parentheses because that's important. And then I'm going to get an answer of 76.298. Again, to the nearest foot. So that would be 76 feet. Okay, I hope this is kind of starting to make sense. We'll do one more. This is one that shows up on your homework, it shows up on your practice test, and it shows up on your test. So I wanted to go over how to do this one because a lot of us were struggling, okay? So a person is watching a boat from the top of a lighthouse. The boat is approaching the lighthouse directly. When first notice, the angle of depression to the boat is 1452. When the boat stops, the angle of depression is now 4510. The lighthouse is 200 feet tall. How far did the boat travel from when it was first noticed until it stopped? So let's draw a picture of this, okay? So I've got my lighthouse, I've got my boat, and I've got my angle. The first spot that they see the boat is over here, and that's at an angle of 1452. Then they look again, so I'm going to draw a second triangle, and this time the angle is 4510. The lighthouse is 200 feet. That doesn't change. What changes is the distance, and what they're asking you for is the distance from this first point to the second point. I'm going to call this, I'm going to call it D for distance, okay? So what I need to know, there's no way for me to figure out D right now. This is not a right triangle, and I don't have the information to be able to figure this out with a non-right triangle. What I do have is two right triangles that I can put together. So I'm going to start by finding this distance right here. And I'm just going to set up, again, I have tangent, opposite over adjacent. So tangent of 45 degrees 10 feet is equal to 200 over x. I'm going to divide 200 divided by the tangent of 45, 10, close my parentheses, and I get 198.839. I'm going to store this number in my calculator's memory just so that I have the exact decimal that I need, okay? So now I have found x. That puts me closer to finding D. Now, if I can find the distance of this whole side, which I can because this is a right triangle, I can subtract the 198 and I will get the distance of D. So let's say the distance from the corner to the corner is 500. I subtract 198 and I get 300 something, okay? So I'm going to set up another one. This time I'm going to do tangent of 1452. And that's going to be equal to 200 over, and I'm going to say, I'm going to call it y. I'm going to call this whole length y this time, just so I don't confuse myself with too many variables, okay? I'm going to divide again, so 200 divided by the tangent of 1452. Don't forget to close your parentheses, and we get 753.418. That's the total distance of the long side. Now I'm going to subtract that 198, which I put in my memory. I can just hit recall and put it back up. And I get a difference of 554.579. And we want to round this to the hundredths place. So I'm going to make that 554.58. And that is feet. Sorry, it's a little messy. But hopefully that kind of helps you with this one specifically. And all the ones that you'll see on the homework, the test, everything are set up the same way, different numbers obviously, but set it up the same way with the two triangles. Solve for the short side, solve for the long side, and then subtract them to get that D, that distance that you need that the boat traveled, okay? Hopefully this helps you out, makes a little more sense. If you're still having trouble or still having questions, let me know, okay? I'm very happy to help. Take care.